Hello everyone. We are talking about human population growth here, and we are comparing what we did in the last section of last chapter where we were talking about arithmetic and geometric sequences. And so the math that we're doing here kind of correlates with that, and we're just using that to compare to a specific topic here about the number of humans on Earth right now. And so we want to get into that right here. And so hopefully you have printed the PDF that I provided for you just above this video. And you need that to be able to fill in some notes as we go, and for you to be able to make comments in this discussion board on this topic. So if you haven't done that yet, pause this video, go back and get that PDF and print it to where you can write down some of the examples that we're doing here. Okay? So, as it says here, world population throughout history can be estimated by this logarithmic function. Now I know we haven't talked about logarithms in this class and so on, but again it has to do with the math that we were doing in the last section. And so here's that formula. N is equal to n sub o, this is called n sub o, times e to the RT power. And I know when it's written out by a computer, when I have to type it on your paper, it looks a lot more complex than this does on the board. But that's what all that notation means. Okay, and here is what all of the terms stand for there. So n is the future population. That's what we're trying to calculate. What is the future population in so many years? Okay, n sub o, that's an O, not a zero, because it's original population. How many people, how many humans did you start with? Okay, the E is a very specific number. It is a number kind of like pi. It is approximately, I'd have to actually put it out on my calculator, 2.413, I think it is. And it has to do with logarithmic growth. It is an irrational number like pi, and very similar with some of the properties. And so that number is used in lots of natural things that happen. It's called the natural logarithm. And so that's the number that's in this formula. The R is the growth rate, so that's a percent, so we have to be careful with that from what we were talking about, changing decimals to percents and so on. And then time is the number of years, just like we've been using in some of our other formulas, and we will use, especially in this next chapter 8. So, okay, so let's look at how the growth rate has been determined actually. Like for example, in 2007, and I saw a chart the other day where it's all been over 1% here recently, but in 2007 it was 1.1, but over time it has been estimated, and you can look up the source for that in here, at 0.428, so just below 1/2 of 1%, okay, annual growth rate throughout history. Okay, so we're going to investigate 4 scenarios. That's what we want to get to here. So scenario number 1 has an initial population of 2, the first Homo sapien couple, right? It takes 2 to tango, right? We need 2 people to reproduce and make more people, okay? A growth rate of that 0.428% that has been estimated over a period of 100,000 years. And so those are the numbers that we're going to plug into this example. And so on your paper, I've already done this one on your paper, but we're going to do it here anyway. And so here's our formula. And so n is what we're trying to calculate. 2, because the original population was 2 people. Okay, so 2 times e, and again, that's going to be in our calculator. And then that's going to be raised to this number in our calculator. The R, 0.0428, because again, we're going to transfer that percentage to a decimal, and we're going to multiply that, and you can move my number 2 here. We're going to multiply that by the number of years that we're using in this example. So we said in this example we would use 100,000 years. And so that's what the E is going to be raised to. Now you have to be a little bit careful plugging this into your calculator, but again, if you use your phone as a calculator, some of you have TI calculators and so on, but if you use your phone as a calculator, and to get it to be a scientific calculator like that, my example is an iPhone, to get it to be a scientific calculator like this one, you just turn it sideways, and it changes into a scientific calculator. And if you'll notice right there is an e to the x key. And so to plug this into your calculator, you would do the parentheses first, and so you'd go, let me just clear it to be sure, 0.0428, okay, multiplied by 100,000 equals, that 4280 is what I'm going to raise e to. So that e to the x is raising it e to that power. So e to that power, error, my calculator, what? My calculator must be broken. I don't know if you can see that. It says error on there. Well, the reason it says error is because this calculator, which is a pretty hefty calculator, can't calculate numbers that big. It can't display them on this display anyway, because it's too large. And we talked, I believe, we've already talked about scientific notation, right? So scientific notation will display on your calculator, and so that will go way big numbers, right? 99 decimal places to the right, okay? And so this number is so huge that I'd have to have a computer to calculate this. And some of you that maybe have some programs like Desmos and so on, Mathematica, those kinds of programs, could try that one. But this number gets to be so big, I can't even calculate it. Okay, so that's a problem. So we're just going to label this as uncalculable. Uncalculable. I don't know if that's even a word, but I believe it is. All right, let's look at scenario number 2. This number is huge. Huge. Okay, number 2, let's look at that scenario. Let's go with an initial population of 2, it still takes 2 to tango, right? With a growth rate of 0.1%, 1/10 of 1%, an extremely low, near zero rate over that period of 100,000 years. So let's drop that growth rate and see if we can calculate that. So n is going to be equal to, our n sub 0 is still 2, because we still need 2 people to start it, times e, raised this time to the 0.001 times 100,000. Okay, let's see if our calculator will do this one. And so if we try to plug that in, so I'm going to clear that error. We're going to go 0.001 times 100,000 equals, and that's just going to take 2 or 3 decimal places off the 100,000, so now we're at 100. Let's try to raise e to that power. Okay, now we get a number. I don't know if you got that same number or not, but now we get a number, 2.688 times 10 to the 43rd power. Remember that little e in the middle means exponential notation or scientific notation. And so that decimal point right there gets moved that way 43 times. That is still an extremely large number, right? Okay, that's just raising its power. Now we got to multiply that by 2. So now we have 5.3762342833632 times 10 to the 43rd. That means I have to take this and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to have this number 12. So subtract 12 from that. So 31 zeros. That is a massively large number. Okay? I'm pretty sure we don't have that many people in the world right now. So I don't think this scenario is true. Okay? Let's try another scenario here. Let's go with scenario number 3. Initial population of 2, got to have 2 to tango with a growth rate still of almost 0, but let's drop the number of years down to just 50,000 years. Okay? Let's say the human population has been here for 50,000 years and it's had this tiny growth rate over all those years. So now we're plugging in n sub 0, still have 2 people, right? Times e raised to the power, I'm going to make these parentheses a little bit smaller, 0.001 still, because we're changing 0.1% to a decimal, okay? And we're going to multiply that now by 50,000 years, okay? Let me take a comma there, I wasn't using a comma earlier, so 50,000 years. Let's try that on our calculator. So, let's clear everything out. Okay, so now we got 0.001 times what? 50,000. 50,000, right? Equals, now we just have 50, okay? And we're going to raise e to that power, so I'm going to hit the e to the x key. And so now we got 5.187, so on, times 10 to the 21st power, but I still have to multiply by 2, so times 2 equals. So there's my answer to this one. So let me write that on the board here. So that is 1.03694110571 times 10 to the 22nd power. So now if I try to write that out, now I would move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Still going to be that 12 places. So now my answer is 1036941105717. 12 places of 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At least I can write this number, right? I have no clue how to say this number. I have a degree in mathematics, and I don't even know how to say this number. I don't know. What do we got? We got millions, billions, trillions, quadrillions, quintillions, 10 sextillion people? What? That's how many people would be in the world right now. I guess my number was so big here I got off the screen even, didn't I? There's my number. Okay? I'm pretty sure there's not that many people in the world right now and never has been, even if you added them up all over time. That's a huge, huge number. So something's wrong here somewhere, right? Something's wrong in our calculation and so on. Okay? So let's change something here. I'm going to go, would this be right pretty much in the middle of the screen? I'm going to change our scenario number 2 here. It's not exactly erased. What is it? I'm going to change our scenario number 2 to where it's a different scenario. And if you printed the page, it would be on the second page here. Okay, so let's look at that one. How about scenario number 4? Let's go with an initial population. N equals n sub 0 e to the RT. N is equal to an initial population of 8. All the other ones started with 2. Okay, initial population of 8 with a growth rate of what we say that it is, 0.428. So this raised to the power 0.00428, right? I didn't write that the correct way over here, but I don't believe this is still that calculable. Okay, we'll run that in the calculator, but I don't think that still comes out to a number that your calculator. I still believe it gives you an error, but I made a decimal point error in that example, didn't I? So 0.00428 over a period of 4,800 years. Okay, so multiplied by 4,800. All right, let's try this on our calculator. So now we have, I want to clear all that out. So now we're going 0.00428 times 4,800 equals, so that e is raised to that power. Okay, so e raised to like the 20.5 power. And it gives us, oh hey, we don't even have an e to the whatever number now. And we multiply that by 8. Is that right? Times 8. Okay. Let's see what that comes out to. So this number is actually readable here. This number comes out to 6,687,069, 288. Let's round up. We'll make that 289. Okay. Well, I can read that number, right? That's 6,687,069,289. That's doable. Now, if you pause this for a second and go out on the web and do a Google search for human population, The human population right now on Earth, I believe, is about 7.6 billion people. Give or take a billion, right? Over that time period. Different plagues, different things, so on, have caused this to go up and down, this growth rate, and so on. And actually, this could probably be calculated. We could calculate this again with that being 4,850 years, depending on your estimation of what that time frame represents. But we're pretty close here. I mean, way closer than 10 whatever. What was that? Sextillion, sextillion, and this number not even being calculable. That number, there was no way we were going to read that number 2 example. This is pretty close, right? Within a reasonable calculation error of some type with these numbers, okay? Those are way off, right? Okay, so we have a pretty good calculation here. Let's figure out what number 4's scenario is. Okay, so there's a place on there for you to put the current population. It's about 7.6 billion, okay? And so what is this scenario number 4? Can anybody tell me what that scenario is? And I wish I could get responses from you here. But why are we starting with 8 people? Why are we at 4,800? I changed that. Why are we at 4,800 years? 4,850, somewhere in that range, right? With the normal, what the calculated growth rate is and so on. What is this scenario? Some of you may be ahead of me already. Some of you are still trying to figure out what that scenario could be. Okay. Well, according to the chronology of the Old Testament, the Great Flood happened approximately 4,800 years ago. Some range at 4,300, some range at 5,000. I've heard it even maybe a little bit more than that, but from the timeline that I did back when I was in Bible college, this is around the range that it would be. Okay? And again, you Google that and you search a little bit, and that's what you'll find. Well, where's the 8 people? Well, the Great Flood, coming out of the ark, was Noah and his wife, his 3 sons, right, and their daughters. And so all of that together comes up to 8 people. And so the human population came from those 8 people after the Great Flood, because the Bible is very specific. Every living thing on the earth was wiped out, right, about 4,800 years ago. And mathematically, it comes out pretty close. Again, over time, plagues and wars and so on. This growth rate is going to go up and down and so on. But from what we calculated out, this is pretty close. What are these other scenarios? Number 2 I erased, but what are these other scenarios going on? Well, if you look at that, we started with 2 people, which, by the way, I don't know where those 2 people came from, right? Somewhere, somehow on Earth, and I know I'm being facetious here, but a male human evolved, bubbled up out of the ooze, whatever it was. A female human, somewhere on Earth, bubbled up out of the ooze, evolved, whatever. Somehow, close enough on the Earth, Earth's a pretty big place, close enough on the Earth to where they could get together and tango, right? To where we started this reproduction going and started the human population. Pretty far-fetched, but okay. This one was at least a number we could write out, and that was an estimation of the human population being 50,000 years at a barely growth rate. Okay, if you think about it, the first 2 people, when they had 1, that's a 50% growth rate. And so at the beginning, it's way high, but this is barely any growth rate for 50,000 years. Most evolutionists would say that the human population has been around way longer than 50,000 years. And that's why we started these other ones at 100,000 years. That's what most evolutionists say, is that the human population started somewhere around 100,000 years ago. Well, there's no way. How could that possibly be from these numbers that we got? Where are all those people? And where are all the bones of all the people that died over the years? We should be over our heads everywhere on earth in bones from all the people that have died in that time frame from these huge numbers of people. It's just crazy. Okay? So, the goal here is, the main question is, which scenario sounds more mathematically sound to you and more reasonable? Okay? This is pretty close, pretty accurate. And by the way, we have people out there saying that the human population is growing way too big. The Earth cannot sustain us. and so on. I just threw some numbers here on the paper to give you some realistic facts about that. And I put, and in fact on your paper I may have 50 right there for the 4850, but I put that 7.6 billion people, if you put all those people, everybody in the whole earth, just in the state of Texas, each person would have almost 1,000 square feet each. Now you got to think about that a little. Have you ever lived in less than 1,000 square feet? I have. I've lived in a dorm. I've lived in an apartment. Each of those being less than 1,000 square feet. Okay. Let's say that we put all those people instead in the state of Alaska. Okay. In Alaska, we would each have about 2,400 square feet. That's about the size of my house. I share my house. Well, I did share my house with 3 other people. Okay. But in this instance, I would have 2,400 feet to myself. If everybody in the world was just in the state of Alaska. So I don't think that human population is a problem yet. If evolution was true, we would be having major problems going on with these massively large numbers that we can't even say. All right? I want you to think about this. I want you to think about what I've put out here for you. Think about the math behind it. Think about kind of the comparison of creation and evolution. And give me your opinion in the discussion board. Thanks, guys.